I'm going to explain what is a scalable test automation architecture. We're going to see copy-pasting the same class, which is obviously a bad practice. Then we're going to utilize some base classes. I'm going to explain how you can use our file configuration for creating separate builds. Scalability allows the framework to handle a high volume of tests without bottlenecks, ensuring smooth execution even as the test suite grows. You can also control the number of concurrent threads or processes used by any unit through this level of parallelism attribute. Why we need this thread lock? Thread local is a class in C# that provides thread local storage of data. Depends on the execution of the outcome of test 2 or vice versa. This is problematic because if the first test fails or it's skipped, the second test will also fail due to missing preconditions. I encourage you always to make tests independent and whenever possible, each test to be able to run in isolation, creating its own test data. Flags, also called feature toggles, allow you to turn features on and off without redeploying the application. Hi guys, greetings from Bulgaria. I'm Anton and this will be our last module part of the Advanced Test Automation Framework Development course. This time we're going to discuss how to design scalable test automation. But before we begin, please subscribe to the channel, hit the ring bell so that you get notified when new videos are published on the Lambda Test YouTube channel. Also check the awesome Lambda Test blog because there are many detailed articles that can help you to be a much better test automation engineer. Now, in the links below, you will find reference resources, all the related articles and other helpful YouTube videos, and the link to the GitHub repo. I suggest to clone the repo and work besides me. This is the repo Polaris-wide test framework, and if you have watched some of the previous modules, you know that I'm not creating separate repos for the modules, but instead I'm creating separate branches. So this time the branch is called Scalability Test Automation. You will find also some jump links to particular topics. Now let's begin. Here are the topics that we're going to cover. First, shortly, I'm going to explain what is a scalable test automation architecture, why we need it. After that, bit by bit, we're going to refactor the framework to support scalable test automation execution, like running tests in parallel. Right now, the framework is not ready. For a reason, I did that because otherwise we had to make it much more complex from the beginning. But I think now it's the moment to refactor and add some C# stuff there to make it thread safe. In some of the parts, we're going to use thread local. In other parts, we're going to use walk statements. And in third parts, we're going to use the lazy. After that, you're going to see a demo how to run some of the tests in parallel using the Lambda Test Cloud. And we're going to discuss 3 different designs of your tests if you want to execute them in parallel. We're going to see copy-pasting the same class, which is obviously a bad practice. Then we're going to utilize some base classes. I'm going to explain how you can use our file configuration for creating separate builds. So there are many different variations depending on your context. So it's good to know all of them. And of course, some of the bad practices and best practices, not designing your tests so that they depend on each other. The first test, creating data for the second and verifying the data in the third. Obviously, this won't work if you run all of the tests in parallel. The last piece that maybe deserves a whole module or a course by itself is how to handle global settings in your application, feature flags. Again, this is a big topic, but we are going to discuss just the part that concerns our tests when they execute in parallel. And how we can design to work with those flags and how we can group our tests so that they don't collide with each other when they need to modify a particular global setting or a feature flag. So let's begin by discussing how to design a scalable test automation. A well-architectured test automation framework is essential for scalability and efficiency. It's not just about automating tests, but ensuring the framework can adapt to the growing complexity of the project, especially when it comes to parallel execution and configuration management. Scalability allows the framework to handle a high volume of tests without bottlenecks, ensuring smooth execution even as the test suite grows. Parallel execution is key to improving the feedback loop, significantly reducing total test execution time. By running tests simultaneously, we can deliver faster feedback to developers. For example, executing tests in parallel can cut down a suite that would take hours to run sequentially into minutes. This optimization requires the framework to efficiently handle test distribution across threads and manage global settings, particularly environments like Lambda tests, where multiple configurations are run concurrently. In the end, parallel execution enables faster releases while ensuring the framework remains scalable and adaptable. Let's see how we can refactor our tests to run in parallel. For the job, again, you need to clone the specific branch that I told you about. In our demo project, demo system test, I created a new namespace called Scalable. You're going to find all of our tests. First, we're going to begin with these three. I implemented again tests for this to-do application. Let me really quickly remind you what is this application. Here is the application. It's very popular demo website. It's called To-Do MVC. Here, the same to-do application is rewritten on different popular technologies like React, Angular, Vue.js, etc. When you click on a particular technology, the rewritten to-do application is open. And obviously, we can add to-do items here by coffee, by milk, by car, and we can check, delete some nodes. We can verify how many of them left. You can filter them, and that's it. Yeah, we can reorder them or check them. That's it. Right now, I want all those tests to be executed on Lambda tests, so I'm going to use the native features of our framework that we built. We're going to run them from the latest version. On purpose, I have, instead of using test case attributes, I just created multiple of those tests with different items. We're opening technologies, and we're verifying a little bit different stuff so that we can simulate a suite with tests, right? Because I want to run them in parallel. I haven't implemented page objects or other more complex design patterns. All of the methods that are using our framework are put here. All of those methods will be run on Chrome. I copied absolutely the same class 2 times, and we're going just to change the Lambda test attribute, and I'm going to mention that I want to execute the same test but on Edge and then on the latest version of Firefox. Since we have 3 classes, Unit allows you to specify how you want to run tests in parallel using this parallelizable attribute. This attribute can be applied at different levels: assembly level via this keyword assembly 2 dots, on a class level, or on a method level. It has different values for this parallel scope, which you can use to control the level of parallelism. We have all, children, fixtures, and self. Children means you're going to run the child tests or individual tests within a fixture in parallel. If you say fixtures, this means that we are going to run the test fixtures or the test classes in parallel with other test classes. You can also control the number of concurrent threads or processes used by any unit through this level of parallelism attribute. This limits the number of threads up to 5. I'm not going to use it. I'm going to use all of my available cores. When running tests in parallel, it's crucial to avoid shared state between tests that can lead to race conditions. There are a few strategies, like in a minute we're going to start refactoring our code to use thread-safe mechanisms like thread local. Because if you think about it, every test fixture will open a session. But if you remember how we structured our framework from before, everything is static, which means that we cannot use the same session for different tests. It will be a complete disaster. One test will navigate to one page, the second one to a different one. They will search for different elements. Obviously, we need each thread or process to have a separate instance of iWebDriver and to hold a separate session to the Lambda test. This is exactly what we are going to do, but first, let me demonstrate how we run the tests in parallel here. Of course, if you run them from the CLI, there are different commands, but right now I'm going to show you how to do that in Visual Studio. You just select the 3 files and then click Run Tests. Let me open the specific builds. You will notice that we have right now 3 tests with the same name. This is for a reason, because in the 3 of them, here we're using Chrome, here we're using Edge, and here we're using Firefox. This is happening because we are running in parallel the fixtures that have absolutely the same tests. Here I already executed all of them. For one of the technologies, we actually have a bug and it's not working properly. But all of the other tests were executed successfully on the latest version of all of those browsers. Also, I added some labels here. Later, I'm going to show you how we can use those tags from latest and others with the specific version so that we can filter by them. Here, I have another one that we are going to see later during the module. Utilizing these settings, you can filter the test results, and here I applied a specific global setting, enable promotions, but we can also set some tags for the browser version. They're running right now. I'm going to stop that. And instead, let's begin talking about how actually discuss what changes I applied so that we can run them in parallel. As I said, by default, if you don't apply this, you will see that this totally doesn't work. The first place that we need to start is our driver factory. I already applied this particular refactoring and I used the keyword thread local. Before, we had these static properties for holding a reference to the browser configuration, to custom driver options, especially to the wrap driver. Why we need this thread local? Thread local is a class in C# that provides thread local storage of data. In simple terms, it allows each thread to have its own separate instance of a particular object. This ensures that each thread operates on its own data without interference from other threads, which can be crucial in scenarios like parallel test execution or multi-threaded applications where shared state can lead to race conditions or data inconsistencies. So each thread access here the thread local variable get its own independent instance of the variable, meaning the state it's local to the thread, to the process, right? Values stored in this thread local variable by one thread are isolated from values stored by other threads. This eliminates the need for explicit synchronization mechanisms like walks for that variable. We're going to use walks, but in other scenarios. The thread local instance exists for the lifetime of the thread. Once the thread terminates, the associated data is automatically garbage collected. Now, why are we using thread local? Probably some of you know that we have actually a specific attribute here called thread static. Why are we not using thread static attribute? While the thread static attribute also provides thread local storage, it is less flexible than thread local. For instance, thread static does not support initializing the values for each thread, like thread local right here. Furthermore, thread local can be disposed when no longer needed, making it more efficient in resource management, right? Why I haven't wrapped actually all those properties directly in thread local? I did this for a reason, because when you have a thread local, in order to access what's inside this thread safe storage, you need to call this value property. And if I have implemented this type of refactoring directly on the properties, this was going to force me everywhere inside my code to go there and update the properties. This would lead to many compilation errors. This is why I left my properties, but inside my properties, I use these thread local static variables that are, again, thread specific. And from now on, when you use the driver factory, this means every test fixture parallel process will hold a separate instance to the driver factory. I implemented the same thing for mobile. The second change should be inside our base classes, these two here. Why? If we check, we have, if you remember, when we talk about troubleshooting, we added this exception. There isn't a mechanism inside a unit or MS test. Inside this test context, it doesn't know what was the error of the test. So we need to wrap this static exception that we are catching from the app domain, first chance exception. Otherwise, it will lead to very strange behavior in the framework. Where we use these exceptions? Inside our web project, we built this Lambda test results plugin. This is one of the places. If you open this Lambda test results plugin, for those of you that watch the video about troubleshooting, you remember that we have this Lambda test hook for sending the exception so that you have access to the whole stack trace, the actual exception message. If this exception, because it's static, if we don't make it thread local, this means that it's possible to see an exception from another test, which will be really bad. It will really complicate the troubleshooting. So this is one of the places where we need to update that. Now, in MS test, because the class initialization, the class init method is static, because of that, we have a little bit more complex logic for holding all of the initialized test classes. And because many fixtures can access that at the same time, I'm using another mechanism called lock. This synchronized access to ensure that the test classes are initialized only once in a thread safe manner. We're going to use lock in a few other places where it's not a thread specific, but this path will be accessed from multiple parallel processes. In our web tests, if you remember, when we were talking about test data, we're using quite extensively web APIs. In order to access our web APIs, inside our pages, we have this app. When we go to core, we have web test. Inside web test, this is the base class for all of the web test classes. We have access not only to the web app, but also to the app of the API. Here, for a reason, I wrap the API client in a thread local. While our REST client from the REST sharp is generally thread safe, if you are managing multiple requests in parallel using the same instance, you need to make sure you handle headers and other options carefully. You might want to create a new REST request for each request execution to avoid any shared state issues. If you watch the configuration module, you know that we have two mechanisms for working with configurations depending on your context. You can rely on the options design pattern and use static options classes, or in some more complex scenarios, we can directly use these JSON files. We are not working directly with JSON or parsing this text. Instead, we have a configuration service that is deserializing that into C# model classes. In order to work with it in parallel, I implemented a few changes as well. This was my previous code, private static read-only 𝐼configuration root. Everything that is static and you're not changing it, probably you need to be careful about it. Particular refactoring will be needed if you want to execute your test in parallel. In order to understand what is lazy, we need first to discuss what is a deadlock. A deadlock is a situation where two or more threads are blocked forever, waiting for each other to release a resource they need to proceed. In simple terms, it's like a circular waiting scenario where each thread holds a resource that another thread needs and is waiting for a resource that other threads holds, resulting in a permanent standstill. Lazy provides built-in locking mechanisms to ensure that the initialization happens only once, even in multi-threaded environments. This is used for lazy loading. If you remember, we implemented lazy loading when we were discussing the adapter design pattern. Lazy is very good option because of this built-in mechanism, but also the configuration initialization will only happen when it's accessed for the first time and potentially improving the performance if the configuration is not always needed. The other code stays absolutely the same. We wrapped our 𝐼configuration root that comes from Microsoft extension configuration. Similarly to the thread local, this lazy gives you initialization inside the constructor using lambda expression. We need to make sure to set this isThreadSafe property to true in order to start this built-in locking mechanism. Another part, so that we don't mess up everything, is our plugin execution engine that we use in our observer design pattern, part of the plugin architecture. Before, we were holding all of our plugins inside a hash set. In order to prevent deadlocks, maybe you can use lock, or maybe it's safe just to wrap the hash set inside thread local. This is important so that multiple plugins are not executed multiple times. If you watched the previous modules about security best practices, you remember that we introduced something called key vault for keeping secrets inside the cloud. This key vault, Azure Key Vault, is using this secret client. Right now, I'm using this static read-only lock object again. This ensures that only one thread can execute the critical section of the code protected by the lock statement. This will prevent any race conditions and deadlocks. For settings or for specific browser versions, because imagine that inside our tests, I showed you like 3 classes, but this is only if we want to run the test on the latest version of the browsers. However, imagine that if we need to support at least 3 versions, 2 versions behind the latest. There are so many files, right? Obviously, this is not a good practice to copy paste all of the tests and all of the logic, right? This is why another strategy here, if you're not going to utilize the configurations that I'm going to mention in a minute, is to create such a base class where you move all of the tests, you remove the test fixture, you mark the test class as abstract so that you're not able to run all of those tests inside the test explorer. I copied all the tests in all the utility methods, not ignore, and that in all of those classes, they're just empty classes deriving from this base class. The only difference lies inside the lambda test attribute that my plugins are using. We change here the version of the browser, and later we're going to discuss if you have separate builds for that. I apply different categories. In this way, we can execute all of those tests in multiple threads. Let's run them. this will execute all the tests inside lambda test multiple times. I already did that here, but I'm going to show you that this is happening. All right, we are waiting. Let's see. Yeah, they start executing. Here is the new build. We have 9 parallel tests from the different fixtures. We have those labels 𝐻126. We have Firefox 128. We have Chrome latest, etc. Later, when you click on tags, you can see all of those tags and you can filter by them. We can see all the tests that were executed on from 127. This is very helpful so that you can filter later particular problems that are happening. This is one of the ways how we can execute those tests on different configurations. This is particularly useful if you want inside your runs on every execution of your continuous integration to run all those tests. However, sometimes this is not needed. Maybe you can create separate Azure DevOps builds. We can create copies of this particular build and create many of those configurations for the different browsers. Many times we call these tests compatibility tests. They are not needed to be executed every day. Many often we execute them once per week or even once per release just to check that everything is fine. Most of the time, executing on the latest version is completely okay. To be able to have this shorter feedback loop, we are not executing them against all the different variations of the browsers. We are not executing all the tests, but just the smoke test suite. We do the same in some of the enterprise projects that I'm part of. We have such compatibility tests for specific instances of the application built for specific clients where they have different configurations and settings, etc. But again, we're not running them continuously, and we want just to execute these particular builds a few times. But we are creating separate dashboards inside the report portal for that. It will depend on your context, but another very efficient way of doing so without creating such additional classes is to create different instances of these test framework settings, and inside the different files you're going to change here the browser version, browser itself, maybe the different resolution again, to depend on the context of your application. If we check our test results, you will notice that our walk is complete mess. This is happening because Logger is actually static. Right now, when 9 parallel tests are running, they're printing on the console at the same time. This means that you see one line from test 1, then from test 3, then from test 6. It doesn't matter, but this log, when you see the PDD logging, when you check the raw logs inside Jenkins or Azure DevOps or GitHub Actions, they will be a total mess. They're completely useless. We need to refactor the logger so that we see a particular logs only for a specific test, the complete log, in the right order, instead of having this messed up logging. This particular refactoring will be a little bit more challenging. If you remember, we put our logger inside a specific namespace inside Polaris-wide core. We're using the logger quite extensively in order to support this BDD logging. Years ago, I thought that this is not very useful feature. However, many of our clients actually found it very useful, and they use it for troubleshooting. They use it for finding out what the test is doing. If we take a closer look, you will notice that in a minute I'm going to show you the thread safe logger. This is the not thread safe version. It's static utility class. This is the not thread safe. It's static read only. This is why it's printing at the moment when you ask the logger directly on the console or inside the file. The thing that I want to do is not print immediately, but collect all of the logs inside a particular collection that it's thread safe, and then print it one by one, all of the logs. This is exactly what I implemented in my thread safe logger. I have 2 thread local storages. One of them obviously is holding the logger. And inside this thread local storage, I have a dictionary of string, and the value is a list of strings. The key will be the current executed test, but its full name. The namespace, the test class, and the test itself, which is unique. Then inside the list will hold all of its related walks. In the end of the test, during the test cleanup phase, we're going to print all the messages one by one. We're going to wrap it, as we'll see in a walk statement, so that we are sure that we're going to print them in the right order. This is our S-walk buffer. S comes from that because it's static. Also, I added one more property called current test full name that we are initializing inside our lock plugin. We have inside the walk info methods. I'm using this accumulate walk method. This accumulate walk, first, we're checking. We need to use this value everywhere because it's thread local storage. This is actually accessing directly our dictionary. We're checking, do we have a key for our current test full name? If not, we're adding the key, the current test full name, and we are initializing a new list of string, an empty list. Then we're getting the current thread or current process ID so that we can add it to the log. Also, we're printing the datetime now, the log level, and the message using string interpolation. We are adding them to the specific list of logs for this test. The log level is this info error warning because later we can control that via settings. I added again here an object called flush log because I'm using this log statement so that only one parallel process at a time can print all of the logs. This will ensure that the logs are following the exact order, iterating through the list of the logs for this particular test, getting it from the dictionary. We are iterating it, we are printing it on the console, on the file, everywhere that we configured, and we are cleaning the logs. That's it. This is this flush logs, which is a new method. Since I don't want every time manually to call the logger to flush all of the logs, I created, using our plugin architecture, I created logger flush plugin, which is very simple. It's deriving from our plugin. We are implementing on before test cleanup. We are calling logger.flush logs, which during the test cleanup phase will just print all the messages. The only thing that you need to do is to replace this implementation with the thread safe logger. One more thing, in order to implement the tags, you need the tags that I showed you in Lambda test. They are not available in the Lambda test automation capabilities generator. You need to navigate through the Lambda test documentation. Under the how-to guides, you'll find an article called Group Test Using Custom Tags. We need to create an array or a list with the tags as strings. After that, we need to call this capability, set capability tags, custom tags. In order to support that, inside our driver factory, I added one new hash set. Why hash set? Because I don't want multiple tags to be repeated, like from latest, etc. Hash set is just holding unique values. Later, during the starting the grid, when we initialize all of the grid options, we are adding all of the tags. For the particular browser and the browser version, I added them here, driver factory tags at browser description, browser version. What is this get description? This is enumeration. I used this custom implementation that we built before. I added this description attribute and using a reflection. This extension method get description is reading just the text here. When I use my num.getDescription, I'm reading this string. We're adding the browser string and then the browser version string. If we have any other tags, later when we execute that, for example, for the settings and the feature flags, we are going to add them here as well. We need one more thing actually to change. in order all of those logger stuff to work. If you remember how we created those event handlers for the BDD login, we introduced new event and delegates for all of the components of those events. They're static. By default, if you subscribe multiple times this event, you will see multiple logs. This is why we need to apply this refactoring. You cannot directly implement thread local to the event. We need this private static read-only variable wrapping the event handler itself. The thread local ensures that each thread hits its own independent copy of the event handler. This means that multiple threads will not share the same clicked event handler instance, avoiding race conditions. When a handler is added via the clicked event, the code first checks if the clicked has been created for the current thread by checking is this value created, and if it hasn't been created for the current thread, the handler is assigned to the clicked value. And the same we're doing when we're unsubscribing for the event handler. You need to apply this. I added this for the button, for the anchor, and for the text field, as well as for our validate methods. But we need to apply that for all of the components and make them thread safe. Let's move to the next subject. In the context of automated testing, making one test dependent on another is considered a bad practice. It's especially problematic when tests are executed in parallel, as the execution order is not guaranteed. Test 1 depends on the execution of the outcome of test 2, or vice versa. This is problematic because if the first test fails or it's skipped, the second test will also fail due to missing preconditions. For example, test 1 is registering a user. Test 2 relies on the first to log into the system. Then test 3 is making a purchase for the same user, and the fourth test is verifying the order inside the user's account profile. When tests run in parallel, there is no guarantee of the execution order. This means test 2 might run before test 1, resulting in a failure because the items it expects do not exist yet. So, test suites become fragile and harder to maintain if the structure or sequence of the test changes. Tests that depend on others may break, leading to false negatives. I encourage you always to make tests independent and, whenever possible, each test to be able to run in isolation, creating its own test data. We discussed that multiple times during the design pattern series, and also here when we were talking about APIs. For example, this test users factory, we use it to create separate users. I created one short example for that. It's part of the scalability namespace. You can find it right here. To do tests with order, I use the order attribute part of NUnit. This order will force NUnit to run them in this particular order. However, this is not guaranteed if you run them in parallel. For example, this first test is adding to the items, then the second one is verifying those items. Many often, when particular items are really persisted inside the database, many people were using this approach, but again, it became a disaster when you tried to run them in parallel. And not only in parallel, but as I explained, if the first test fails, then all others are failing as well, leading to many fragile tests. Another way of how people are solving this problem, or thinking that they're solving it, is that they're using, if you select multiple tests, if you open the context menu, you will find that there is an option for adding them to a playlist. This is a special mechanism in .NET for creating test suites. We can create a new playlist or a test suite. This is a manual process where you can control the order inside the playlist. There is no automatic way to specify the order here in the UI when creating the playlist. Even if you reorder them, because this is possible. If you open here, I have one such a playlist, I saved it here. So this playlist file is in an XML format, which means that you can control the order of the execution inside these playlist files by manually editing the .playlist file and reordering the tests in the XML. However, this is not a recommended practice, because if the tests are set to run in parallel with this parallelizable attribute, the playlist order might not be enforced because the tests could be run concurrently on different threads. Even though controlling the order in a playlist is possible, try to avoid making tests dependent on the execution order. Self-contained tests that do not rely on prior state are more robust. Now we are going to discuss settings. I prepared one sample table holding settings. Global settings are configurations that apply across the entire web application and affect its behavior for all user or instances. These settings often control core functionalities such as UI preferences, for example, dark mode, default language, specific features or behavior. Security settings, enabling, disabling two-factor authentication. Regional settings, currency, country-specific features for compliance with regulations, formatting settings, and much more. So when dealing with a large system that has, for example, 1,000 global settings, controlling various behaviors and running 10,000 tests across 10 parallel builds or processes, there is a high risk of test failures due to settings conflicts. This happens because one test may update a global setting that another test running in a different process relies on. Without carefully managing and analyzing these dependencies, settings can be overwritten, leading to unpredictable failures and unreliable results. To avoid this, you need to analyze the dependencies between settings and tests and create settings dependencies trees or such tables. These trees will show how different tests depend on a specific settings, helping you group tests in a way that minimizes conflicts. Based on this analysis, you can decide which tests can safely run in parallel without causing failures due to shared global settings. It's really helpful to have such documentation about all the settings, some of the default values, and possible values for the settings. Here is the other relationship, the table that helps us to analyze all of those dependencies. First, we have the name of the setting, the global setting that controls some aspects of the system. Then we have the test group that depend on or modify this setting. The dependency type describes the nature of the dependency, whether it's visual, functional, security, etc. In the next column, called conflict potential, we put how likely it is for this setting to cause issues in parallel execution, high, medium, and low. And then we have another one for safe for parallel execution, indicating whether tests relying on this setting can be run in parallel with others. Of course, we can overcomplicate this. I suggest to have separate groups of tests that do not rely and this is exactly what we're doing in many enterprise projects that have so many settings. Believe me, if you're watching whole course and if you need such a framework, probably you will hit this problem. This is why I'm mentioning it in exactly this particular module. Safe parallel execution, some settings like max items per page or items in cart limit can be safely used across different tests in parallel without causing conflicts, as long as the tests do not modify the setting during execution. By analyzing setting dependencies, you can group the tests with non-conflict settings to run in parallel. For instance, UI visual tests can be grouped separately from functional or security tests. To demonstrate how to handle application settings in web tests, especially when running in parallel, we'll build a mock setting service with these 10 different settings to show how to safely manage these settings within your tests. We'll integrate these settings with Lambda tests for scalability. You can later integrate that with Allure and the report portal. You can use their tagging options as well. You will find that I have here a namespace called app settings. This is where I implemented that. I'm calling this mock setting service. Most probably inside your setting service, you're going to use a web API to update those settings. I encourage you every time when your test is relying on a particular setting to update it to the setting that you're expecting. My mocking service, at least the first version. In a minute, I'm going to show you a second version that it's thread safe and it's event driven in order to allow supporting BDD logging. But for now, let's keep it simple. I have enumeration with all of those settings from the table that I showed you. Then we have the mock setting service holding the current settings and the default settings values. We are initializing them in the constructor. And you have methods for getting the setting, restoring to the default, and getting all. I have one test here, test class. In a minute, I'm going to explain these attributes. I used the plugin architecture. I have created this plugin. But for now, let's see the version without plugins. So I am initializing the mock setting service. Maybe we need to refactor that. In all of the tests, we are first setting the settings that we need, enabling the dark mode, how many items maximum we can have per page. And after that, we're getting a particular setting and we can verify something. At the end of all of the tests during test cleanup, we're restoring them to their default values. Of course, I don't want every time to repeat this code for restoring or setting something. I think it's very beneficial to create such attributes. When I have the attributes, we can build a plugin using the observers design pattern so we can set those settings before the test execution and then restore the default during the test cleanup phase. So I created this things attribute inside this plugin namespace. We have properties to the settings enumeration, its value, its object, because it can be a boolean, it can be a string, it can be an int. I have one more property for whether we want to set tags in Lambda test or not. Later, you can utilize the flag for other tools. Right now, I made my attribute to be sent on top of only classes, not tests, but you can change that. I said that we can apply multiple of those attributes because we can have multiple settings that needs to be changed. And inside my plugin, I have two methods: on before test initialize and on after test cleanup. We have a special method called getSettingsAttribute. The return time of this method is list of tuple. A tuple is a lightweight data structure that can hold a fixed number of elements, each of which can be of a different types. In C#, tuples are useful for returning multiple values from a method without needing to create a separate class or a structure to hold them. Because here I'm getting multiple attributes this time, not a single attribute. The select method, which is part of link, we use it to project each settings attribute into tuple containing its setting and value. When we have the list of these tuples, we're initializing the mock setting service, and I'm just for each of the settings. I'm calling settings, set setting, and maybe I forgot here to branch that, because if you remember inside the attribute, I have this set tag. Every time I'm adding the tags with this settings, item 1, item 2, this is how we work with tuples. Because you can have more than two. We're adding those tags for the settings. As you can guess, inside the after test cleanup, we're doing the same, but this time we're restoring to the default. This is how our plugin with the setting works. Let's discuss quickly what a feature flag is. Then we're going to wrap up this module and a course. So the feature flags, also called feature toggles, allow you to turn features on and off without redeploying the application. This is especially useful when running tests with different configurations for user segments, devices, and geolocations. They help you test features in isolation, control rollouts, and run API tests without disrupting other functionalities. There is a difference between feature flags in remote configuration and global settings. The feature flags control whether a specific feature is available, dark mode, toggle, beta feature access, and they usually have binary state, on and off, true or false. While the remote configuration, they adjust operational settings, for example, the currency type, the API endpoint, that aren't directly tied to feature availability. Feature flags are ideal for managing toggles across different environments, test suites, while configuration defines how those environments behave. Please note, we will focus on how feature flags concern our tests running in parallel. We won't discuss whether you need to use similar flags in the automated tests. Usually, these feature toggles, they need to be short-lived. The discussion about feature toggles deserves a whole video. We'll just focus on this particular part only. So, when to use feature flags before showing you the actual demo code. Introducing a new feature to a small percentage of users and gradually ramping up as confidence grows. I'm going to show you some Lambda test features that can help you test that. Compare different versions of features across segments to measure performance and behavior. Control features exposure to specific groups, beta testers, to gather feedback before wider release. Flags let you merge incomplete features into the code base and deploy with feature turned off until ready. A small number of feature flags can generate a large number of possible test combinations. For example, 3 flags, 8 combinations, 10 flags, over 1,000 combinations. And managing these combinations increases complexity, so I suggest you to create similar tables like we did for the settings. You need to account for both enabled and disabled states, which requires a solid test matrix for different user segments and geographies. I prepared one last demo for that. We have another namespace called feature flags. We have a feature flag service similar to the one for settings. I made this already thread safe. All those dictionaries with the default and the current state are wrapped. They're thread local. You can use even thread safe dictionaries if you want. But also we have some event handlers in order to support BDD logging. We have BDD logging feature flags handlers. As I explained, I built such a event-enabled mock setting service for the setting service as well. There are some events here, settings retrieve, updated, restore, and we have some implementations for the BDD logging as well. An enumeration with the feature flags, types, some event handlers for the BDD logging and others. Very simple methods, a static method for getting the feature flag, setting the feature flag, and restoring to the default. That's it. And static methods to raise the events. And I have created a similar plugin. We have attribute similar to the settings, but this time we hold a property to the feature flag, whether it's enabled and whether we need to set tags inside the Lambda test. And inside the plugin, we are doing absolutely the same. We are just for eaching, but this time I made our feature flag service static. It's a utility class. We are getting the attributes and we are for eaching them and calling our service and restoring them. The interesting part is that you will see that I'm not using only my feature flag attributes, but the so-called user fragments. It means that you can use the feature flags to turn on a specific feature only for particular devices, for browser version, or for your geolocation. Let's say India or Finland. You can test the feature only there. In order to verify that, Lambda test can help this geolocation. We are using it later in other plugins that are combined the Lambda test. We are going to execute all those tests in this particular place, which is really awesome. We can change the time zone, we can change the locale. Again, it depends how your feature flag is working. Many companies, they use these feature flags just to roll out a particular feature to a set of devices, for example, Samsung devices or iPhone devices or particular version of Android. You can use Lambda test to test these feature flags and user segments and you need to check definitely when the feature flag is on and off. You can check the code. It's absolutely the same code like the settings, but I just use the utility feature flag service. If you use the plugin, you don't need to use the utility class manually. We covered a lot of stuff. First, we discussed this scalable test automation architecture, why you need it. Then we refactored a big chunk of our framework to support parallel test execution. We reviewed some of the features of the C# that can help to make our code thread safe, discussing the thread local, the walk mechanism, lazy, and others. We made our logger work much better when we run our tests in parallel. We reviewed a few strategies of how you can run your tests in parallel using any unit parallelizable attribute, and how you can use base classes or use separate builds using our configuration management using files. After that, we discussed some bad practices, why it's not good to using order attribute and your tests to be dependent on each other. Last but not least, we covered what are the global settings and feature toggles and how to handle them properly when you run your tests in parallel. Thank you for watching. If you have any questions, put them in the comments below. Also, check the awesome Lambda test blog, the community website, and don't forget to get your free certification about NUnit, JUnit, Appium, WebDriver, and many other technologies. Thank you, and see you in other courses.